Welcome to this explainer. Today, we're exploring a massive, literal sea change happening right below the surface of the ocean. We're talking about an entirely new, virtually invisible way to power the UK. We are diving deep into the future of British tidal energy production.
So, could underwater turbines really power an entire nation? I want you to imagine an energy source so powerful and, crucially, so absolutely predictable that it could allow a country to completely replace its gas, coal, and nuclear plants. I know, it sounds like science fiction, right? But it's actually much closer to reality than you might think.
Okay, let's dive into this. Here's our roadmap for today. We're looking at Britain's renewable energy future, how tidal turbines work, wind versus tidal power, the best tidal sites, and finally, overcoming underwater challenges. We're going to unpack the tech, the prime locations, and the real-world hurdles engineers are tackling right now. Section 1. Britain's renewable energy future, replacing fossil fuels with the ocean. The stakes here are absolutely massive. We're looking at the very real prospect of Britain becoming entirely self-sufficient in renewable energy. Think about what happens if tide, wind, and wave power are fully developed. We're talking about drastically cutting carbon dioxide emissions and literally closing down gas, coal, and nuclear plants. It even opens the door for the UK to export renewable power to the rest of Europe. And perhaps most strategically, it creates a massive export industry for other island nations, places like Japan and New Zealand. This is a huge deal, especially given a major missed opportunity in the past. See, Britain actually originally developed wind power, but then kind of just abandoned it for 20 years. That basically allowed the Dutch to step in and turn it into a massive industry. With undersea turbines, Britain has a fresh chance to lead the world and, not repeat that exact same mistake.
Section 2. How tidal turbines work, the mechanics of the deep. Now, what's really interesting here is how surprisingly familiar this underlying technology actually is. The core principle is basically the same as wind turbines. You have constant, entirely predictable tidal currents flowing past these machines, which turn underwater blades that act a lot like a ship's propeller. Each turbine is mounted on a sturdy tower, and that tower funnels the generated power straight into the national grid using heavy underwater cables. To give you a real sense of scale, these towers actually stick right out above the surface of the water and are lit up to warn passing ships. And here's a highly specific, kind of fun logistical twist. They're specially designed to be lifted straight out of the water for maintenance. Why? Well, mainly so engineers can scrape and clean seaweed off the blades. It's a very practical, gritty reality of the tech that just brilliantly brings these marine machines to life.
Section 3. Wind power versus tidal power, the comparative advantage. This is a true David versus Goliath scenario. We're pitting the established, towering giant of wind power against this emerging underwater tidal tech.
Look at wind power. It relies entirely on unpredictable weather, it was abandoned for decades by the UK, and it frequently faces fierce environmental pushback. Tidal power, on the other hand, operates with absolute clockwork predictability. The tides are always going to roll in and roll out. Plus, because these massive blades turn pretty slowly, they're considered completely safe for fish and other marine creatures, meaning environmental objections are highly unlikely. Dr. Abu Bakr Bahaj, who leads sustainable energy research at the University of Southampton, hit the nail on the head. He states that the prospects for energy from tidal currents are just fundamentally better than from wind entirely because of that rock-solid predictability. But wait, here is where the sheer scale difference gets truly mind-blowing. 3 times the power output. Because water is so much denser than air, a marine turbine blade only needs to be 1/3 the size of a wind generator to produce 3 times as much power. Think about that efficiency for a second. A blade just 20 meters across, sitting in roughly 30 meters of water, vastly outperforms its giant wind-based equivalent. It's a total game changer. Section 4. The best tidal sites, the map of power. So where exactly are these underwater hubs going to be located? Well, it turns out Britain has hit the geographical jackpot. EU research identified 106 potential tidal sites, and an overwhelming 80% of those sit right around the coasts of Britain. That leaves just 20% for the entire rest of the European Union. The absolute best spots are nestled right between islands or along heavily indented coastlines where those tidal currents truly roar. Let's zoom in on just one of those locations to really grasp the staggering potential we are talking about. The Pentland Firth site, which is positioned perfectly between Orkney and mainland Scotland. With banks of these turbines under the sea, this single site alone could produce 10%
of the entire country's electricity. Just one site. It perfectly demonstrates why tidal energy is such an unprecedented powerhouse. And the scale really is staggering. To put it into perspective, Britain's largest and newest nuclear plant, Sizewell B, produces 1,200 megawatts of power. By comparison, the Alderney tidal site in the Channel Islands is capable of a projected 3,600 megawatts. That's exactly 3 times the power of the nation's biggest nuclear plant. And crucially, it's expected to deliver all this at prices that are competitive with modern gas turbines, entirely undercutting the ailing nuclear industry. Dr. Bahaj has actually done the bulk of the work focusing on this specific Alderney site, where the currents are incredibly intense. Because that single undersea farm will produce significantly more power than the Channel Islands actually need, there's a fascinating cross-border energy loop planned. The farm will power the islands, feed its massive surplus directly into the French grid, and then that exact same power will be seamlessly re-imported back into Britain via existing underwater cables. Pretty brilliant, right?
Section 5. Overcoming underwater challenges, the hostile deep. So the crucial point here is, well, it's not all smooth sailing. The ocean is a brutal, highly corrosive, and incredibly tough place to put precision machinery. Let's look at the main technical enemy the engineers at the University of Southampton are currently fighting. It's a phenomenon called cavitation. Basically, low pressure forming right behind a rapidly turning blade causes little air bubbles to materialize. Now that sounds harmless, right? Bubbles, but it absolutely isn't. When these bubbles inevitably collapse, they cause intense, violent vibration, which can significantly damage the massive turbine blades over time.
But the team is tackling this head-on. As Dr. Bahaj notes, they have to test a number of blade types to avoid this damage. But, and this is the key takeaway, he says all the signs that we can do it are good. They are also carefully monitoring other tricky variables, like submerged debris randomly floating into the spinning blades. Ultimately, the key is making these turbines exceptionally robust, because the sea simply takes no prisoners.
Fortunately, they have a massive head start, thanks to decades of deep-water research from the North Sea oil industry. Right now, research is highly advanced at the University of Southampton, with a literal test station arriving shortly. Over the next 3 years, backed by a hefty £215,000 grant from the EU and the Department of Trade and Industry, the tech will be rapidly refined. And looking just 5 to 10 years out, the incredibly realistic goal is to actively install fully commercial marine turbine farms right around the coast.
It's an absolutely thrilling timeline for technology that could fundamentally rewrite how we generate electricity, which leaves us with this final thought to ponder today. If the dark, hostile ocean holds this much predictable, incredible power, what other invisible solutions are just waiting to be uncovered? Thank you so much for exploring the future of tidal energy with me in this explainer.